Good morning, everyone. This week here, the lecture is going to be a little shorter than normal, and it's because we're only focusing on this one aspect of what we covered last week, which is this discussion on correlations and correlational studies. It's really important that you get a strong sense for what correlations are. And once you start getting into your methods classes and some of your experimental classes, later on, as you start getting into statistics, you'll lean heavily on the knowledge of correlations. And so, while some of this information may seem a little redundant to what we covered last week, my hope and my goal is that we can talk about this on a little bit more of an in-depth level. Okay, correlations is something you have to know, and correlations are sort of a big first step in how you might understand your data, how you might understand the relationship between two or more variables in the study that you're conducting. Correlational research is important because it tells us where to look for relationships, right? If you have variables that are associated with one another, then it gives you a good starting point from where to analyze your data, from where to continue to try to assess your hypotheses and to try to understand how these two variables are related in the natural world. So today we're going to talk very briefly about correlation on just a more in-depth level. There will probably be some type of activity on the website. And if you're in chapter 2 now, go ahead and continue reading chapter 2. We'll start the next chapter probably next week or the week afterwards. Okay, so when we talk about correlations, we are talking about a measure to detect how strongly or how weakly two variables might relate to one another, right? When we look at correlations, we're not measuring only from a positive standpoint, we're also looking at negative standpoint, okay? So we do not measure correlations from 0 to 1. We measure correlations on a scale of -1 to +1, okay? You can see my arrow right here. The correlation of +1 in the natural world means that two variables are perfectly correlated with one another. It means for 100% of the time, whenever a correlation, well, whenever a variable goes up, then the other variable that it's being associated with also goes up. If the variable goes down every time that happens, then the associated variable also goes down with it. So it's a perfect correlation in the sense that you might think of this +1 as meaning 100% of the time, these two variables are perfectly positively correlated. Okay. A positive, a perfect positive correlation. This -1 then means that two variables that are related together are perfectly negatively correlated. Okay. Now remember what I said last week. This predicts a very strong positive relationship. This predicts a perfectly negative or inverse relationship, right? So if we're doing +1, we find a correlation of +1 means that variable A relates to variable B 100% of the time. In other words, every time variable A goes up, variable B also goes up. But every time variable A goes down, variable B also goes down. So it's a perfect positive relationship. Even if both variables go down and score together, if they do it perfectly every time, that's still a perfect positive correlation, right? Here, we have a perfectly inverse relationship. So every time variable A goes up, variable B goes down. Every time variable A goes down, variable B goes up. This is perfectly negative, right? So that means 100% of the time, whenever A goes up, B goes down, or whenever A goes down, B goes up. So perfect positive relationship, perfect negative relationship. In the center, is 0. Right? 0 means that there's no relationship whatsoever between these two variables. Right? A might go up, B might do who knows whatever. Right? Or A goes in one direction and B is doing whatever. So it means the two variables are not related to each other at all. So if the two variables are not related to each other at all, then there's a 0 relationship. Now, coefficient R is how we define what a correlation is, right? So if we say we have a correlation of 1, we would say R equals 1. We have a correlation of -1, we would say R equals -1. Okay, so R then is the coefficient that we use to define what the correlation is. So in sum, perfectly positive, no relationship, perfectly negative. Now, here's the rub. In the natural world, nothing is perfect. If you were to read a journal article and it said that the authors found a correlation of 1, you should be very, very suspicious. Now, I haven't mentioned this yet because we haven't gotten into it, right? But because this is on a scale between 0 and 1, you can have correlations of 0.1, right? 0.2, you have a correlation coefficient of 0.5, right? Typically, strong correlations are going to be considered somewhere between correlation of 0.5 and 0.6. That's for both sides. You have a positive correlation of 0.5 to, 0.7. A correlation coefficient of 0.5 to 0.7 is going to be considered moderately strong, right? If you have a negative correlation of 0.5 to, or I guess it would be negative 0.5 to negative 0.7, that's considered moderate. You're likely to see correlations around that. If you're ever reading a scientific journal and the author's like, we found a correlation coefficient of 0.9, right? So almost perfect. We found a correlation coefficient of -0.9, right? Almost negatively perfect. You ever see a journal article that says, we found a correlation of 1. We found a correlation of -1. That is your hint to be very skeptical about the findings of that paper. The natural world is not perfect at all. So if someone did a study and they said that they found an exact perfect correlation, their statistics are most likely wrong. Their study needs to be replicated, and you need to take a good hard look at both their methods and how they analyze their data. Perfection or near perfection does not exist in the natural world, and our statistics and our methods do not capture that. Nobody's study should almost ever be at R equals 0.9 or R equals -0.9. That should almost never happen. So, as you can see, I've jumped ahead a lot in this schematic of understanding variables. But the point of the matter is, when we are talking about correlation, we're simply talking about the extent to which we can measure the pool or the effect or the associationship between one variable and the next, described on a numeric scale. Okay, so let's say we want to talk about income and education, right? So we've got these two factors here that are kind of driving each other, if you think about it, right? The higher your education, we would assume the higher your income, right? But if you have higher income, then you can afford a better school to get better education. Does that make sense? So income and education in that way feed one another and they're related to one another, right? We might think about cigarette smoking and health, right? The more cigarettes you smoke, right? So that variable goes up, variable A, the less good health you're in. So B goes down, right? Conversely, the better health you're in, the less likely you are to smoke cigarettes. So what kind of, I look like an idiot right now, and that's okay. I do it for science, do it for teaching. So if your health is going up, but your cigarette smoking is going down, what kind of correlation is that? What kind of relationship is that? Hopefully you are participating, even though I can't see you. That's a negative relationship, right? So those two variables tend to also feed into each other. Right? So as I've said, positive and negative. Now, negative correlations are not bad. It just means that they're inverse, okay? So put this in your notes somewhere where you can continue to monitor that, right? So positive correlation, the higher X is, the higher Y is, right? And negative correlation, the higher X is, the lower Y goes, right? So the higher education you have, the greater your income should be, right? The more you exercise, the lower number of cigarettes you smoke. So positive correlations, as I said, are variables that are related in the same direction, right? So they go up in the same direction. So we're going to keep beating that horse until it's dead, and then we're going to beat it some more. Okay. The higher it goes up, sorry about that. It's early morning here, and individuals are just they got their big tires on their big trucks, and they're ready to go. So the earlier it is in the day, the louder the truck is. So that could be a correlation of some type, right? Okay, so the higher your education is, the higher your income level should be. The higher your income level is, the higher quality education you should be able to get. As I said before, 0.7 would be considered a very strong moderate correlation. So we would say that there's a correlation of 0.7. We would say R, correlation coefficient, R equals 0.7. That means there's a very strong correlation that shows this strong relationship between these two variables. As you can see in the animation, as one goes up, the other goes up. As one goes down, the other goes down. The direction doesn't matter. What matters is, are they both going in the same direction? Okay, so are they both going in the same direction? And if they are, that's a positive correlation. This is how it might look on what's called a scatter plot, right? Scatter plot is simply to what extent, right, do the different points, do the different X and Y indices cohere to this slope line here, okay? The tighter these points, the closer they are to the line, the stronger the correlation, okay? So in a perfect correlation, all of these points taken from these different individuals, okay? These are different people who we asked them what their income was and what their education was, right? So some are a little bit higher, some are a little bit lower, and this right here is sort of that slope line that goes in between, okay? The tighter these points are on a whole around this line, the stronger the correlation. So this right here is what a 0.7 looks like. As you can see, the general trend is for these data points to be closer to the slope line here, right? Now, if this were a perfect R equals 1 relationship, each one of these points would be directly on the line. Okay. Each one of these points would be directly on the line. Here, they're still pretty tightly around the line. There's no points that are way over here or everything. So we could say it's still a pretty strong relationship. Overall, for most people, they've experienced the higher level of income as a result of having a higher quality education. So it's strongly positive. Right. So negative correlations then, the opposite direction, right? So the more you smoke, the less likely you are to exercise. The more you exercise, the less likely you are to smoke. I've met people who exercise and smoke. They're very weird individuals. It's hard to do both of those things, especially since they don't go together, right? But it can happen. So you've got two variables that are related in the exact opposite direction, okay? So now, as you can see, the higher your health, the lower the number of cigarettes consumed, right? Now, one of the things that you should notice is for the positive correlation, your slope line goes up. And for a negative correlation, your slope line goes down. But it's still a 0.7 relationship. So you can still see most of these data points huddled around the slope line. Okay. Again, if this were a perfectly negative relationship, everybody in our study who had good health, none of them consumed any cigarettes at all, right? So it's a perfectly negative relationship. If that were to happen, then every single one of these points would be directly on this line. Every single one of them. It would be just one line and it would be blue from all the points being directly tightly on the line. Okay. There's variation between each of these points. Each of these points represents a person in our study, right? Who we asked this question to. So some smoked more cigarettes than others. Some smoked none. Some smoked a little bit. But overall, in our data, we see that most are huddled fairly close to the slope line. And for most of the people, the higher their health levels, the lower number of cigarettes they were smoking. So we covered this example somewhat last week, right? A positive correlation is going to slope upwards. A negative correlation is going to slope downwards. A zero correlation, points are all over the place. So even if you were to put a line in between in either direction, you would see that overall statistically, none of the data points, i.e. none of the participants in our study, are really close to that slope line, and none of them are close enough to the slope line to have any meaningful results. In other words, those two variables are simply not related. So positive slope line, positive correlation, trends upward. Negative, trends downward. Zero, all over the place. So if we were in class, we would go through each of these, right? But for now, on your own, given the information I've given you, given what's in your book, I want you to go through these. I want you to decide whether the correlations are positive or negative, okay? So go through each of these and then figure that out, right? The first one, let's do the first one together, right? A study of married couples showed that the longer they had been married, the more similar their opinions on social and political issues were. Is that a positive correlation, a negative correlation, or no correlation? Well, let's see. The longer they had been together, married, the more similar they became. So as one went up, length of years married, the other also went up, opinions on political and social issues. That's a positive correlation. So go through these, figure them out, and then maybe we can discuss later on. So what are some things that we should think about correlations, advantages and disadvantages? First, they do show whether two or more variables are related, and they also allow for general predictions between those variables, right? However, they usually do not permit identification of cause and effect. So we can't say, right? So in our married example, we can't say that the length of years together caused political opinions to be similar. We can just say that the longer they were together, the more similar those opinions were. So it does not show cause and does not mean cause. Correlation does not mean causation is a catchphrase that I've been hearing since I was in your seat as an undergraduate at my own intro class. I'm here to tell you now that you will hear this phrase in your intro class and in your undergraduate career all throughout your time as a psych major, all throughout your master's program, all throughout your doctoral program. So get used to that phrase now. Your mentors, your advisors, your professors, everybody who cares about you as someone in this field is going to beat that into your head over and over again. Correlation does not equal causation. It just shows us the direction. They're not the same. It does not tell us what caused a thing, right? Why doesn't it tell us what caused a thing? It's because of this issue called the third variable problem, right? So let's say we're looking at the choice of video games that are played. And let's say we're looking at measurements of aggression. So does the more video games you play cause higher levels of aggression? Right? Well, we can't say it causes it, but we can say we've noticed statistically the more violent video games someone plays, the higher their levels of aggression are. Right? But there could be some third variable that's causing these two things to work together, right? So let's say that an individual has decided to play video games, right? And one of the reasons they've decided to do that is because they've been ostracized at school or isolated because they've been bullied. But because they've been bullied for so long, at some point they themselves become aggressive and start acting out. Well, we know that both the video game playing and the aggression went up. Both of them went up as a result of being bullied. Okay. So being bullied is working on both of these mechanisms. So if we take being bullied out and let's look at this, right? And we just hide that bottom part, it looks like, and this should be separated out to where I should have had it to where being bullied doesn't appear until later. But just take that out for a second. It looks like choice of video game influences aggression. But that's not the case. Choice of video game and aggression are both being influenced by this aspect of being bullied. So you can't say that two variables cause each other. You can only say how strongly they're related to each other. That's all you can do. You have to do other statistical tests in order to determine what the actual cause is. And that's when you get into experiments. correlations and correlational studies are good because they tell you where first to look. So if I was doing a study and I found out that most of you were playing violent video games, as a result of that, most of you being aggressive, it tells me I need to start looking into what else might be going on to cause this. So I've looked at my data and I have an R equals 0.7 between your playing video games and your levels of aggression. Now that I have that information, I'm like, so I need to start figuring out how to drill down what's going on between these two variables. And that's where I start to do my experiment. That's where I start to look further into the issue. So there's also an issue of confounding variables, right? So this is something that we would normally talk about if we were in class together, but a confounding variable is like something that you didn't really account for is affecting your data, right? So this relationship here, let's say we look at class attendance and test scores, right? Well, there might be some confounding variable that's affecting why these two are going in the same direction, right? So I will put this on the website for you. But what I want you to do is I want you to think. We know that the two variables are related to one another, right? So this variable of frequent class attendance and high test scores. But we can't say that frequent class attendance causes high test scores. So what might be other variables that we look at as to explain this relationship? I will put this on the website. I will have you do it, okay? And then maybe we can talk about this a little bit next week. So a quick, easy week for you. So if you haven't started chapter 2, but now you should be starting chapter 2, and we'll continue to get into this as we go further into the semester. All right. Hope you all have a good day. Hope you all have a good week, and I hope to talk to you soon. Enjoy the sun. Get out. Get some fresh air. Continue to socially distance yourselves. Continue to wear a mask, and continue to be patient and extend grace to one another during this time. All right. Talk to you all later.